So in this question, we're asked to take the relation and rewrite it as a function of x. Okay, so the first thing that we're going to do is we're going to try and arrange all of our x terms on one side. So we have 2y is equal to negative square root of x minus 2x plus x plus 2 squared. We're going to divide both sides by 2 and simplify to get y is equal to negative root x divided by 2 minus x, because the 2's are going to cancel there, plus x plus 2 squared divided by 2. And as you can see, that is sufficient as a final answer. I don't need to simplify x plus 2 squared. Next, I'm asked to evaluate this function at f of 1. So what I'm going to do is I'm going to take the equation that I had before and I'm going to substitute 1 in for x. So doing that gives me f of 1 equals negative square root 1 divided by 2 minus 1, since I just had the x left there, plus 1 plus 2 squared divided by 2. Simplifying, I have negative 1/2 minus 1 plus 9/2. These two right here will sum up to 8 over 2, which is 4, and 4 minus 1 will be 3. So I'll input a 3. And finally, in step 3, I have to talk about the domain of this function. So the only problem that we're going to have with this function is our square root. So once again, looking at f of x is equal to negative root x over 2 minus x plus 2 squared divided by 2. We'll be able to put in anything we want for x in here, because we can square negative, positive, doesn't matter, anything here. But our issue will be with the fact that we have a square root of x here. We want the square root of x to be greater than or equal to 0, which means we want x to be greater than or equal to 0. In interval notation, this will be stated as 0 to infinity, with a bracket on the 0 because we're including it from this equal sign. In the next and last step for this question, we're being asked to take the function that we have and describe or determine the implied domain of the function and express our answer in interval notation. So the only issue that we have here is with this square root of x. Notice that there's no denominator with any x's, so we don't have to worry about a denominator being equal to 0, although in the future we may. We do have a square root, and we always want our square root to be greater than or equal to 0. So these are the things that we check for. And then if we're looking at our numerators, notice that this right here doesn't matter what that x is going to be, because after I square it, whether it's negative or positive, that will end up being positive, and this x right here is in the numerator, so we don't have to worry. So we have the situation here where we need to examine a radical. So we look at a square root of x and say, well, it must be positive, which means x must be positive, which means in interval notation that we are including 0, and it says greater than or equal to 0, so we're going to infinity. We never include infinity.